Hello everyone, my name is Glantser and I'm really excited to be here. I'm going to talk today about modernizing your data platform. But before we start, let me go through a few very important slides. One of them is about everything that PaaS has to offer, because really PaaS has so many things to offer. Lots of training opportunities and networking opportunities. We've got local user groups all over the world. Almost in every country and major city there is a local user group. There are also virtual groups around special interests. We've got SQL Saturdays, usually a one-day free event organized by local volunteers. Nowadays, everything is virtual, so it makes a really interesting opportunity for everyone to join and attend events like SQL Saturday from anywhere in the world. It's really amazing. There are PaaS marathons with back-to-back live webinars, and also the PaaS Volunteers program, which allows you to be a volunteer and contribute and help the community. Lots of opportunities there as well. All of those free resources are on the PaaS website, so visit paas.org and find everything that PaaS has to offer. I really ask you to fill your session evaluations. It's really important to me as a speaker and also to the conference organizers. So by the end of this session, please fill the session evaluation so I can learn how to improve myself for the benefits of the community. Thank you. And now it's time to introduce myself. So again, my name is Guy Glantser. I'm a data platform MVP. I am also the CEO and founder of Madeira Data Solutions. We are an Israeli-based company. We provide solutions and services worldwide around the Microsoft data platform. I'm also the leader of the Israeli user group and data platform community, and I co-host the SQL Server radio podcast alongside Eitan Blumin, and I'm really enjoying it. So that's about me, and now let's talk about building houses. No, I'm kidding. But imagine that you want to build a house like this, okay? You wouldn't start by digging a hole in the ground and putting the blocks on top of the other, right? You would probably start with some planning, with a blueprint, okay? And this is the same for any software project, I guess, but specifically for a modernization project. If you want to modernize your data platform, and I'm not just talking about migrating to the cloud. It can be upgrading to a recent version of SQL Server. It can be all kinds of things. We'll talk about the options later. If you want to migrate, you need to plan first. It's really important to do proper planning. And my goal here today is to talk about the methodology, the project aspects of the modernization of the data platform, how to plan the project, how to take it from A to B, from one point to another point successfully. Okay, so we're going to concentrate on the planning phase and on the project management aspects and the methodology of this project. A little bit about technical stuff, but not too much technical stuff. Okay, and when I look at a modernization project, I look at 5 steps. First, plan. Again, I guess I'll spend like 80% of the session about planning. But once we have a solid plan, we need to develop scripts and tools and everything we need for the successful migration. Then we need to test everything. And then, of course, the actual deployment. And there is also monitor. Now, monitor is not exactly only at the end. You need to monitor from the beginning. So monitoring is part of each of the other steps. And I'll talk about that later. But monitoring is really important. So 5 steps. Let's start from the planning phase. So with the planning phase, I usually ask customers the 5 WH questions. Why, where, what or how, when, and who. Okay, let's start with the why. It might sound trivial, but this is a really important question, I guess, for any project that you start, but specifically for a data platform modernization project. And the question is, why are we doing it? And again, it might be obvious, but from my experience, sometimes it's not. Sometimes people just don't ask the question. They just start migrating or upgrading SQL Server or whatever. Sometimes they ask a question, but each person in the organization has a different opinion about the answer. Okay, so maybe the CFO thinks that you are doing it in order to save costs, and the DBO thinks that it's simply cool. Okay, and if you want the project to be successful and you want everyone to think it's successful, then you need to align the reasons for this project. So some examples of reasons for why would we like to modernize data platform. Maybe the current infrastructure can't scale. You have an old infrastructure with storage that is not fast enough, or you don't have enough free space in your storage. Maybe the server is not fast enough. It's an old CPU architecture. You don't have enough memory and you can expand, and so on and so on. Okay, so that could be a good reason to modernize. Another very good reason is end of support. I guess all of you or most of you know about SQL Server 2008 and R2, which is already end of support for quite a long time now. You don't get support from Microsoft anymore for these products. Also, 2012, sometime in the future, it's not too far, is going to go into end of support state. So if you don't have support, you are at risk. You might not get security fixes. And if there are bugs, you will not get support for those bug fixes for Microsoft and so on. So this can be a very good motivation for upgrading or modernizing in general. In some cases, the motivation will be to reduce costs. Okay, if you plan it right, you might be able to reduce costs by doing things better, like maybe consolidating multiple servers into a single server and saving costs, saving licenses costs and hardware costs, and so on. If you are running, let's say, SQL Server 2012 today, there are so many great new features and capabilities in 2014, 16, 17, 19. And of course, if you go to the cloud in Azure SQL Database, for example, you've got most of the features and some more in the cloud. And it can be a really good opportunity, a good motivation to upgrade or to migrate to the cloud in order to take advantage of those features. Things like column store indexes, always-on availability groups, intelligent query processing, big data clusters in 2019. So many great features, depending on your use cases, of course. Check it out. Security compliance is, in many cases, a good motivation for modernization. The current infrastructure, the current software that you run might not comply with your security requirements, and you need to modernize in order to make sure that you are compliant. And sometimes the reason is just to be innovative. Now, if this can be a valid reason, okay, if it's acceptable by everyone, let's say the organization is currently using SQL Server 2005, okay, it's really old, and there is a real problem because HR can't attract talents. They can't attract good DBAs because nobody wants to work with SQL Server 2005 anymore, okay? And it becomes a real problem for the organization. This might be a reason to upgrade to a recent to SQL Server 2019, for example, so that now HR can say, hey, come work for us. We use the latest technology, okay? That's okay. But sometimes, from my experience at least, it's a project initiated by the DBA because the DBA wants to be innovative. They want to be cool. They want to use the latest technology. It's not necessarily something that the organization values, okay? And this is a recipe for failure in most cases, okay? So make sure that everyone is aligned about the reasons. Now, once you know why you are doing it, you should define SMART goals. SMART goals is not something I invented, and they are not specifically related to data platform. They are for any goal setting methodology. SMART goals are specific, measurable, achievable, realistic, and timely. Okay, and this is really important. If you just define goals like we want to do better, we want better performance, it's hard to measure and to say, okay, we made it. This was a success. Okay, maybe one person can say, okay, this is better. Some other person can say, I don't think it's better. It's even worse than before. You need a very good way to measure it. You need a specific goal that you can measure. It has to be achievable. Otherwise, there's no point in trying to do something that is not achievable or realistic. And it has to be timely scoped. Okay, so let's say by the end of the quarter, by the end of the year, something like that. So a few examples. If the current infrastructure can scale, if this is the reason we're doing it, then a SMART goal would be able to serve 10,000 batch requests per second by the end of Q3. This is a very specific goal. It's measurable. It's hopefully achievable and realistic for our organization. And it's timely. It's by the end of Q3. Okay. Another example, if the reason is end of support, then use only the latest version, in our case 2019, in all of our servers by the end of the month. Okay, again, specific, measurable, and so on. Another example, if our reason is to reduce costs, then we want to reduce the monthly database TCO, total cost of ownership, by at least 30% by the end of the year. Now, this might be a very vague goal. Of course, the TCO needs to have a very known and transparent expression formula for how we calculate it. Okay, there might be some Excel file somewhere that we use to calculate the TCO. We need to be consistent. We need to know how we calculate it today, and then we can compare by the end of the year that we really managed to reduce it by 30%. Otherwise, we didn't succeed in the project. Now we need to distinguish between primary goals and secondary goals. Okay, a primary goal is this is actually the reason we're doing it. We want to achieve this goal. If we don't achieve this goal by the end of the project, we are not successful. Okay? The project has failed. So these are primary goals. We usually have 1 or 2, maybe 3 primary goals. So for example, we can have this primary goal. Okay, achieve at least 10K batch requests per second. And also another primary goal, this is related to the migration itself. We want application downtime to be no more than 5 minutes during your migration. Okay, this is really important to us. So if we do all of this migration and we have a downtime of 10 minutes, this is a failure. Okay, we failed the migration, the modernization project. And also no data loss. We can't allow any data loss. Okay, so we have 3 primary goals in this case. We must achieve all of these 3 goals in order to say this is a successful project. On the other hand, we can also add some secondary goals. Okay, for example, we want to set up a DR solution. We don't have a DR solution today, and one of the reasons maybe we want to upgrade to a recent version of SQL Server or to migrate to the cloud, to Azure SQL Database, is so that we have a DR solution. We want to reduce the storage footprint by at least 40%, okay, and create the password column in the users table by, for example, using always encrypted, which was introduced in SQL Server 2016. If we are on 2014 today, then we want to benefit from this new feature after the upgrade. And maybe we want to move to a cloud PaaS solution like Azure SQL Database or managed instance. This might be a secondary goal. The idea of secondary goals, we want to achieve them. This is a great benefit, but they are not primary goals. They are not the factor for success. Okay, if we achieve all the primary goals but not all the secondary goals, that's okay. All right, so these are like nice to have. We really want them, but this is not the reason why we're doing it. So this is the why. We know why we're doing it. We are aligned. Everyone is transparent about it. We have clear motivation. We have clear goals. We know where we're going. Now let's talk about the where. So with the where, first, where we are today. Okay, we need to know what we have today, what is the inventory, and also where do we want to be tomorrow. Let's start with today. There are several tools we can use for the discovery phase to discover what we have today. First, the Microsoft Assessment and Planning Toolkit, or the MAP Toolkit. It's a very old tool, still working today. As far as I know, the latest version supports up to SQL Server 2017, not 19. But it's a great tool to discover what you have today. It's actually much more comprehensive than just SQL Server. It can identify all kinds of servers, Microsoft software in your data center. Here is an example of a screenshot I took from my small network at home. I have, as you can see, only a single SQL Server 2017 instance with several services, and you can generate an inventory report or an assessment report which will give you all the details about all of those servers, so you know for each SQL Server the version, addition, and lots of other information. Okay, so this is a very easy way. If you have, not like my home network, if you have a network with dozens or hundreds of servers, it's an easy way to capture all of the information and generate a single assessment report with the current inventory. That's a good place to start. Another option is the Data Migration Assistant. This is a tool you can download from the Microsoft website as well. It's free. And this tool, it actually has 2 options. One of them is to assess the current infrastructure, and the other one is to perform the migration itself. So in this case, we're talking about the assessment step, and with the assessment step, you can define the source schema, the source server, the source infrastructure, and the destination, the target platform. In this case, I chose the target platform to be SQL Server 2019 on Windows, as you can see here, and the source is a SQL Server 2017 instance in my network. And then I ran the discovery phase again, and the Data Migration Assistant gives you all kinds of recommendations. It finds all kinds of issues. Okay, maybe there are issues with the migration. You can't migrate before you fix this and that. Also, a recommendation like this one. In this case, we have medium recommendations about security. One of them, for example, it identified all kinds of columns in my databases according to their names that contain sensitive data like passwords and PII data and so on. And it suggests that we use dynamic data masking or always encrypted to encrypt or mask those columns, just as an example. Okay, so you can get all kinds of issues and recommendations for your specific environment, for your specific schema. This is the Data Migration Assistant. We also have DBA Checks. DBA Checks is a free open source library of PowerShell commands. It's part of DBA Tools, a really great tool. So you can go ahead and download, and DBA Checks include lots of tests that you can run against your existing servers. This is something that you might want to do not just as part of a migration or modernization project, but as an ongoing process on your current infrastructure, your current servers. And it checks all kinds of things like when was the last time you took a backup, when was the last time you ran dbc check db. If you have, as you can see here, auto close set to on or auto shrink set to on. So you get reports about all of those. You can evaluate how many tests were successful or failed. And it comes, as you can see here, with a nice Power BI dashboard that you can use. So it's really a nice way to get lots of information about your current infrastructure, your current servers before you start the migration. The last one, and there are many, of course, okay? Those are just examples. The last one is SP Blitz, also a very known tool, open source, developed by Brent Ozer Unlimited, gives you the ability to run all kinds of tests against your SQL Server. This is for a single SQL Server. In this case, you can, of course, run it for each and every one separately. And you can monitor the behavior of SQL Server over time. And this will give you some kind of a baseline of how this SQL Server is functioning. It also comes with a nice Power BI dashboard. So here's an example. In this case, the read quantity installs and also the write quantity installs separated by different databases on one of my servers. So you get all of those metrics and graphs, lots of useful information that you can collect about the performance, the baseline of your SQL Server today. And again, I'll talk about monitoring later, so we'll get a little more into more details about that. So this is just a few examples of tools that can help you identify what you have today. Now, where you want to go tomorrow? There are some really important questions to ask here. First, on-prem or cloud? Do we want to stay on-prem and just migrate to a recent version of SQL Server, or maybe a different server, a new operating system, or maybe altogether we want to migrate to the cloud? Move to the cloud, to Azure, to the Microsoft Cloud, for example, okay, in our case, and then there are all kinds of opportunities there. There are all kinds of pros and cons, of course. We don't have time to get into all of those here, but you should ask those questions. You should take into account all the pros and cons, evaluate and decide whether it's good for your organization to go to the cloud, yes or no. If you decide to stay on-prem, so are you going to migrate to a physical server or a virtual server? Nowadays, almost every server is virtual. In some cases, I still see some physical servers here and there. Again, there might be good reasons for physical servers, but in most cases, there is no reason because there are lots of benefits from going virtual, and it's very, very common and mature today, so I don't see a reason to use physical servers anymore. But again, that's a question you should ask yourself. If we go to the cloud, are you going to an infrastructure as a service or a platform as a service? So with infrastructure, we have VMs. You can use a VM in Azure, install SQL Server, or it might be pre-installed for you. You can get an image with SQL Server installed. You can register this SQL Server in Azure and get things like automatic patching, automatic backups and stuff, but it's still a complete VM that you control, that you manage completely. Or you can use platform as a service. You can use an Azure SQL database, or even an Elastic pool, a pool of databases, or a managed instance. It's still a platform as a service, but you get a complete instance, a managed instance that you can manage, including all databases, TempDB, and so on, and almost all features of the on-prem SQL Server. So there are lots of pros and cons, which I don't have time to get into, but you should check it out and decide what's the best solution for you. There's lots of documentation. Okay, so if you just go to the Azure website, go to the Microsoft documentation, you can find lots of documentation about Azure SQL, about everything in Azure, by the way. There's great documentation, very rich and comprehensive. So you should spend some time reading and learning about the various options, the pros and cons, and take a wise decision about what's best for you, for your organization. This might be a very good opportunity for consolidation. And I've seen it in many cases. If you are going to modernize, and today you have 70 different servers with SQL servers lying around with different versions, different editions. One of them has a maintenance plan, the other one doesn't. They have different specs and so on and so on. And it's very, very expensive to maintain all of those servers and also to pay for all of those licenses for the hardware and software. This might be a good opportunity for consolidation. If you are going to migrate to the cloud, for example, that you can migrate to a pool of databases. Each database from one of those on-prem servers can become an Azure SQL database. Or you can migrate to a single managed instance, or maybe multiple managed instances, but maybe just 3 or 5 and not 70. Or if you're staying on-prem, then you might migrate to a new server, a strong one that can host all of the databases from the current 70 servers and utilize resources much better and save a lot of money on licensing and maintenance and so on. So this is something that you need to consider. If you're going to a PaaS, a platform as a service solution, then you don't have a choice here. You get the latest version, like it or not, but you like it. And if you want to go to a virtual machine or an on-prem server, then you need to decide what would be the target SQL Server version and edition. Regarding the version, I usually recommend to go to the latest one. These days it's 2019. Some people might say if it's a relatively new version, if it's a new release, if it was just released, let's wait for the first, second, or maybe third cumulative update. We don't have service packs anymore, so let's wait for the few cumulative updates to make sure that it's stable. Okay, it might be fair. From my experience, well, in some cases this was true, in some cases it was the other way around. Okay, so maybe the RTM, the first release version, was quite stable, and there was a bug that it was introduced in some later cumulative update or service pack. So I don't think it really matters. I think that as long as there is a new version, a release version, not a CTP, not beta, okay, a new version of SQL Server, you should prefer to migrate to the latest version because you can benefit from so many new features. As far as edition, this is interesting because in SQL Server 2016, there was a very important announcement, specifically in Service Pack 1. Lots of features in SQL Server that until then were only available in Enterprise Edition became now available in all editions of SQL Server. Things like partitioning, data compression, and many others. So if you're using, for example, 2014 with Enterprise Edition today, because let's say you want to use partitioning, this might be an opportunity for you to save some costs by upgrading to SQL Server 2019 and maybe downgrading to Standard Edition. You can still continue to use partitioning, and maybe that's good enough for you, and you can save a lot of money on licensing. Okay. In other use cases, of course, you might want to use some really great features of Enterprise Edition in recent versions, like online index rebuild per partition with the ability to resume and suspend the online index rebuild, and some other great features. Okay, so it really depends on your needs. Also, you need to ask yourself, which data models do I need? Okay, so if we are going to modernize, and if we're going to use the cloud, for example, then maybe we don't have to stick with the relational model. Maybe most of our database should be still relational, and we should use Azure SQL, but maybe some of our tables should actually be migrated to Cosmos DB, because they make more sense as a NoSQL database. But today we use them inside SQL Server because that's what we know, that's what we had. Okay, it's a good opportunity to set back and ask those questions. Okay, so maybe that model, that table, that schema shouldn't actually be inside a SQL. It makes more sense as a NoSQL schema. Let's use Cosmos DB for that, or let's use Azure Data Explorer for our analytics. There are lots of new opportunities and data services in the cloud that you might want to explore, and then you might take better decisions other than just saying, okay, we are going to still use SQL Server for everything. All right, so we talked about the where. Now let's talk about the what and how we are going to do the actual migration. So first, are we doing it in place or side by side? So of course, in place is only relevant if we're staying on-prem. But anyway, either on-prem or to the cloud, I always recommend to do the project side by side because then you have more control. You have a new server without all kinds of issues that you might have with the previous one, the old server. And also you have the opportunity for rollback. With in place, there is no rollback. Once you upgrade in place, now you're in the recent version, you can't roll back, well, not easily. You need to set up the previous version again, take a previous backup, and so on and so on. It becomes more complicated. So I always prefer to do it side by side, whether it's in on-prem to a new server or to the cloud. Now, some options that you have for migration. If you are allowed to have some downtime, you have a large enough maintenance window, then you can, this would be the easiest way, you can bring all of your applications and services down, notify your users. And let's say you plan it to take 5 hours. Now you have 5 hours to take the database offline and migrate it to the target platform, let it be on-prem or cloud. Several options there. One of them is to detach the files and move them, copy them to the destination and attach them there. SQL Server can automatically detect the previous version of SQL Server and the new one. And for most of the past, the use cases, it will automatically upgrade the files to the newer version. You need to check the documentation. Some older versions are not supported, and you might need to do the upgrade in 2 steps. For example, start from, if you upgrade from SQL Server 2005, then you can't upgrade directly to SQL Server 2019. Okay, so you need to first install the latest service pack for 2005, then upgrade first to, let it be 2012, for example, and then from 2012 you can upgrade to 2019. Okay, just like detach and attach, you can use backup and restore. It's quite similar. Okay, there are some differences, but it's the same idea. You need to take your application down, your database offline, backup, restore in the target platform. With these 2 options, detach, attach, and backup, restore, you can use them, of course, for on-prem. You can use them with a virtual machine. You can also use them with a managed instance, but you can't use those options with an Azure SQL database. You can't attach, and you also can't restore directly to an Azure SQL database. So if you want to use the SQL database as your target platform, these are not valid options. Another valid option, first valid option for SQL databases is the SQL package utility or the backpack, okay, the ability to export and import the entire database. You can also use the UI in SQL Server Management Studio or SQL Server Data Tools. But if you want to do some automation, then you should use the SQL package command line utility. This allows you to export an entire database to a backpack file, which is actually a zip file that contains all of the schema and data. And then you can ship this backpack file to the target platform, and you can import from the backpack file into the target platform. And this is also supported in Azure SQL Database. This is honestly, this is one of the only the few options that you have for migrating into Azure SQL Database. I'll talk about another one later. We have all kinds of methods for continuous synchronization. We can use always-on availability groups or database mirroring or log shipping for this, mainly those 3 options. And this means that usually you start with a full backup, you restore this full backup in the other target platform, and this is online, okay, so everything is online. Then you start either shipping log backups or synchronizing using mirroring or availability groups. So this is an online synchronization, okay, all the time. And this is good for the cases where you can't afford downtime. You can't afford a long maintenance window. So you ship all the delta, all the logs, and then at some point, this is the cutoff point, you take everything down, all the services, the applications, you take the last log backup, or you make sure that the target platform is synchronized, the database is synchronized, and then you can do the switch. You can bring the database online in the target platform, and you can redirect your applications and services to the new target platform, or by changing the DNS maybe, then you can use the same connection strings in your applications, but just change the name for the new target platform. Those are great options, again, for online migrations with minimum downtime. But again, those options, all of them, availability groups, mirroring, and log shipping, are not relevant for Azure SQL Database. And also, you can use log shipping with managed instance, but not the other 2, not mirroring and not availability groups. Replication is an interesting tool that is actually a good choice for many cases when you migrate to the cloud. You can use transactional replication to migrate to any of the alternatives, but I would generally use it for Azure SQL Database. So this is for me the best option if you want to migrate to an Azure SQL Database. And Azure SQL Database can't be a publisher, but it certainly can be a subscriber for transactional replication. So you can publish from the on-prem database to an Azure SQL Database in the cloud, and then this also allows you to perform an online migration with minimum downtime. So you replicate everything. Of course, there is an initialization phase, then you replicate everything, and then at some point you do the cutoff similar to what I explained before, and you can do this with an Azure SQL Database. And it works great in most cases. Again, I mentioned the Data Migration Assistant before, so you can use the Data Migration Assistant with the ability to not just assess your current inventory, but also to perform the migration project itself. I think it's good for small databases where you can afford the downtime, but if you want to do an online migration for a large database, this will not be a good choice for you. You can also use Azure Database Migration Service. It's a separate service in Azure that will allow you to migrate your databases, whether online or offline migration. So you can try that. But again, from my experience at least, I prefer to use known methods that I'm familiar with, that I feel comfortable with. And this means if I'm going to migrate to a VM in the cloud or to an on-prem server, a different server, I would probably use availability groups and then do the cutoff. And if I want to migrate to Azure SQL Database, I would probably use transactional replication. But of course, it depends on your use cases, your requirements, and your existing skill sets. This is also important. When you migrate to a new server, whether it's on-prem or VM, don't forget to migrate all of the server-level objects. Also, some of them are relevant to manage the instance, not all of them. And you need to take care of things like logins, jobs, SQL Server agent jobs, linked servers, SSIS packages, and so much more. Lots of objects, not just objects at the instance level, but remember you should also take care of objects at the server level, the operating system, the file system. So maybe, for example, you have an on-prem SQL server, and there is a folder on that server, the local server, and this folder contains files, and there is a job that once a day checks for files in that folder and loads them into a table. Okay. Now, if you're going to migrate to a new server and you migrate everything, but you forget to create that folder, of course, the job will fail. Okay. So just an example, you need to take care of all the resources, folders, files, objects at the operating system level, at the instance level, permissions also, so that the new server is identical, has everything it needs, just like the old server. If you're going again to VM or local on-prem, then you need to take care of everything. If you're going to Azure SQL Database, then you need to find alternatives for many of these things. For example, jobs. You don't have SQL Server agent in Azure SQL Database, but you have Elastic Jobs that you can use, and you have other options like Azure Automation, Azure Functions. There are all kinds of ways in Azure to create automation, to create scheduled jobs. You can't use linked server, for example. If you need access from one database to another, then you can use external tables, for example. It's a separate feature, and you need to migrate your code to convert your database to use external tables instead of linked servers. Or maybe redesign the whole thing and bring everything together into a single database. Okay, so there is some development work there if you want to migrate to an Azure SQL database. Okay, let's talk about the when. And basically, when I say when, it's really important from a project management perspective to have a clear timeline and to be transparent. Everyone needs to know about the timeline. When do we start the development? When do we start the testing? When are we going to do the actual deployment? Okay, so each and every step in the progress needs to be communicated, and each person, each stakeholder needs to know what their role and when they need to do what they need to do. Okay, so this is really important. Communication is really important in this type of projects. And again, who is also really important too. There are many stakeholders, many people that are reliant on this project, and they might have a say. And the bottom line is everyone should be communicated. Everyone should know about this project. They should understand, again, why we're doing it, what is the goal, how we're going to do it, when is it going to happen, who is going to participate in this project, and so on. as the more we communicate and the more we are transparent about everything in this project, the more probability that we are going to succeed in the project. So it's really important because some people might have things to say that we didn't think about, okay, like people from data analysts, people from QA, from finance, of course the CTO, the CIO, and so on and so on. All right, what else? We're still in the planning phase, okay, but we still have some other things to take into account. So one of them, for example, is risk analysis. This is important, okay? If again, it really depends. I want to say something. Through this entire session, I'm saying how important it is to manage this project, to document everything, to take care of the planning phase, and so on and so on. Some of you might say, wow, this is an overkill. This is too much. This will take forever. We don't need this. We just have a single SQL Server, and we just need to upgrade it to the recent version. What's the big deal? And that's fine. I'm giving you the entire picture, and of course, each one of you should decide what's best for your specific use case, for your organization. If we are talking about a very important mission-critical environment with lots of risk, okay, we can't risk to have downtime. We can't risk to fail. Then it's really important to do proper planning, and it's really important to perform a risk analysis. A risk analysis means we need to ask ourselves what could possibly go wrong. Okay, and lots of things can go wrong. Maybe we will have a network failure between on-prem and Azure, so our synchronization will fail at some point. What do we do when this happens? Maybe we find a bug after we migrate to the new target platform, a bug in SQL Server or in our application using the new platform. What are we going to do about it? Lots of things that can go wrong. We need to ask those questions. We need to document, write down, okay, if this goes wrong, here is what we're going to do. Okay, write it down, communicate this to everyone. This is really important because if something goes wrong during the actual deployment, you are going to be really nervous. Everyone is going to be nervous. People are going to yell at each other. It's not a good time to start thinking about what we should do. At this point, you need to have it in front of your eyes. Okay, this is what you're going to do. Okay, we already thought about it. Here is our risk analysis plan. You should follow it. It's no time for thinking now. Okay, and also rollback, plan for rollback. This goes with the risk analysis. So if something happens and you decide to rollback, how exactly are you going to rollback? You need to plan. Okay. In most cases, rollback will just, if you're doing it side by side, will just be forget about the new platform. Let's go back to the old one, bring it online again, and continue to work just like before. Okay, and this is okay, but you still have some things to take care of there. For example, if you change the DNS name already, you need to change it back. You need to make sure it's working properly, and some other things you need to take into account. So you need to plan for rollback as well. In some cases, you need to develop some scripts and tools for the rollback process itself. Plan the monitoring part. Okay, it's not enough to say we're going to monitor the environment. Okay, you need to plan for it. How exactly are you going to monitor? What are you going to monitor? If you use, there are all kinds of monitoring tools. You can develop your own. You can use third-party tools. You can use some tools within SQL Server. You need to plan because there are so many things, so many metrics that you can measure. What is considered a good performance? Okay, are you going to monitor CPU utilization, disk I/O, memory utilization, the number of compilations maybe, the number of full scans, the number of deadlocks in the system? I don't know. There are so many things you can monitor depending on what are the pain points you have today and where you're going, what are your goals. Remember, we talked about the goals. So if we have a goal for a specific amount of batch requests per second, naturally we're going to monitor batch requests per second, but there are some others. So you need to decide what should become the baseline. So you're going to monitor this baseline now using the current infrastructure, and then you're going to monitor this in the test environment, and of course after deployment in the target platform, and compare it to the baseline and see whether you made an improvement, yes or no. You need to plan for it. Document everything, write down everything, document your plan, your risk analysis, your rollback plan, of course your actual migration plan, your monitoring solution. Document everything and communicate it with everyone, with all of the stakeholders, and ask for feedback. If you do it, you will get lots of feedback, lots of questions that you might haven't thought about, lots of errors maybe that you haven't discovered before. And as more people see those plans and communicate about them, they will become better and better and better for the successful of the project. So Make sure that you document and communicate this with everyone. Wow, we finished talking about planning. This was the planning phase. And by the end of this phase, you should have a robust plan. You should know exactly what you're going to do, how, where, when, and all the WH questions. Let's talk about development. So a few things I want to say about the development process. Use scripts for everything. Sometimes I see people when they upgrade SQL Server, let's say we need to use a transactional replication, they use the GUI, the user interface. They use Management Studio, right-click, set up publishing, set up the publisher, publication, subscription, and so on. They set up everything using the GUI. It will work, that's okay, but I don't think it's the right way to go, because if you don't have scripts, you should probably need to do it again. Okay, you're doing it now in the dev environment, you will do it again in the test environment, maybe multiple times, you will do it again in production. And in production, if you're going to manually use the GUI, you might get things wrong. Okay, you might do something not the right way, and this might be catastrophic. So you really want to use a script, you want to have a script that sets up everything. You want to document that script, you want to verify that it's working properly, you want to test it and test it again and again, and then you will have the confidence when going to deploy in production that you are using a well-tested and verified script that you can trust. This is really important. Also, when you write a script, you learn a lot from the process. If you just click buttons in the GUI, you don't really know exactly what's going on behind the scenes. When you write your own script, you can also, of course, use the UI and then click the button to generate a script. That's okay, as long as you take the script, learn it, understand it, make the necessary changes, document it, add your comments, test it, that's fine. Now you have a tested script, that's okay. But you should have your own script. It's really important. And then, once you have your script and it's ready, if you need to do this process again and again and again, it's as simple as clicking F5, okay, or execute. So it becomes very easy. So use script for everything. Don't use the UI. Treat this process just like any other development activity. Okay. Again, I see this a lot when I work with customers. They have development teams, they have DevOps, they have well-defined development methodologies. Okay, when they developed the application. But now we have a very big project, a migration project, a modernization project, and they don't treat this project as any other development activity. They just say, okay, the DBA will develop some scripts. They don't use methodologies like source control, versioning, communication. They don't communicate via the same tools like Jira or whatever, okay, in many cases. Don't do that. Treat this as part of your development cycle, okay? So now the next sprint is going to be devoted to the migration project, and this is what we're going to do, and you should use the same tools as you develop you develop the application, develop scripts for your database. Now you should develop scripts for your migration project, okay? If you use the same tools and methodologies that are already well tested and working properly for your organization, why not leveraging them for this project as well? Of course, prepare a suitable dev environment. Don't start running things in production. That's not a good practice. Make sure you have a dev environment so you can play with things. You can try replication or availability group or whatever it is you want to try in your dev environment. Remember to develop the rollback scripts and tools, not just the going forward scripts. Okay, you also need to develop rollback scripts, including cleanup. Okay, so make sure that you clean up again replication, availability groups, whatever it is you're using. As part of the rollback, you also need to clean up everything. And not just as part of the rollback, as part of the actual migration project, you also need to make sure that you have scripts ready for the cleanup after you make sure that everything is okay, everything is a success, and you no longer need this replication topology. Okay, you can drop it. My tip, use DBA tools for everything. DBA tools, again, it's a really great and powerful open source library of PowerShell tools, lots of PowerShell tools that you can use. Instead of inventing the wheel and developing your own scripts, there are many things that are already in there. They are tested and used by the community. Things like migrating server level objects. Okay, so if we talked about migrating logins and jobs and stuff like that, you have very simple commandlet, PowerShell commandlets that you can use to do that very easily instead of developing your own scripts that might take a lot of time to develop and test. Okay, so check out DBA tools. Okay, so we talked about development. Let's talk about testing. Okay. Okay, again, if you care about this project and you want it to be a success, you need to test and test and test and test again. So first of all, prepare a suitable test environment. We talked about a dev environment, that's fine. Now you also need a test environment. As soon as the developers finish developing, now you want to integrate everything together. You want to test it from start to finish in a suitable test environment. This test environment should be as close as possible to the production environment. Of course, this is not always possible, okay? But as much as possible, you should have the same infrastructure, the same specifications, the same configurations, the same data, the same schema, of course. And then you can test it properly, because let's say you have all the servers, just like in production, in the test environment. You have the exact same schema, configuration, everything is the same, but you don't have data, okay? So you just have sample data. Instead of tables with 1 billion rows, you have a table with just 10 rows, just for the test. As part of this test, everything might go smooth, everything is okay, and then during the actual deployment to production, you start getting some real performance issues because you never tested the target platform with a 1 billion row table. You need to test. Test for functionality, test for the correctness, for the data validity, and also for performance. This is really important. You should also test, of course, things like availability and security, depending on your needs and what you expect from the target platform. Okay, so you should test everything in the test environment. And of course, if you have a good risk analysis plan, now is the time to use it and test it in your test environment. So what you need to do is to find a way to simulate each one of those risks of what could go wrong, simulate it, take the network down, for example, and then make sure that you know what to do and that it works, that your plan is actually working according to what you plan to do in this case. So test it and test it again. This is where usually you realize that it's not exactly the way you thought it would be, and this is a good opportunity to revisit your risk analysis and decide what to do when this happens in production. Don't forget to test your rollback mechanism as well. So if you develop the rollback mechanism using some scripts and tools, you also need to test the rollback mechanism, because you might need to use it in production. You don't want to get to the point in production where you decide to rollback and then the rollback mechanism doesn't work. That's not going to be a very nice thing. Of course, test the application. Okay, so if you are the DBA, you're responsible for the database, you are leading this project, then yes, you test everything in the database level, but don't forget to make sure that the application owners, the developers, the product team, they test the application as well, because eventually this is what the database is for, to serve the application. So make sure the application is working properly, do regression tests, make sure that everything is okay. And we talked about this, monitor activity. You should have a baseline before and monitor again after in the test environment and make sure that everything is okay. You don't have any performance degradation or anything else that happens that will surprise you. You should check this in the test environment first. Perform as many dry runs as needed. Okay, depending again of the complexity of the project, of the risk, of the mission criticality of the system, then you might just decide to run once in test environment. You might decide to run 10 or even 20 times until you are satisfied, you are calm and happy with the results, and you minimize the risk as much as possible. It really depends on your needs. Let's talk about deployment, right? So we developed it, we tested it, we have a robust plan, it's well tested, we are ready for deployment. So the first thing is schedule. Okay, make sure that everyone that is involved knows exactly when and where they should be and what they should do. Okay, you should write down the plan, communicate it with everyone, make sure that everything is well understood by everyone. If anyone has any questions, let them ask the questions before actual deployment, not during deployment. I remember all kinds of cases during the middle of the night. We were during a very major migration project. We were during a downtime, and then we realized that one of the people, let's say the IT guy, wasn't available. Okay, and he forgot that he's part of this project, and he wasn't available. It took like 2 hours to get him on the line, and we had 2 hours of downtime more than we planned. Okay, what a waste. So make sure that everyone is aligned with the schedule, that everyone is available. Update your users. Okay, don't forget, this is your product support or marketing role to make sure that you update your users well in advance. We are going to do a major maintenance in order to improve the application during that time. So take this into account. We are sorry for any inconvenience, etc., etc. Okay, make sure you do that, and take notes during the deployment process. Okay, so during those hours or minutes or whatever, the time it takes to deploy, to actually do the actual migration, the live migration, make sure that someone takes notes of what's going on, what's happening, of the timeline. Okay, at 3 a.m. and 14 minutes, we started replication. At 3 and 47 minutes, we took a full backup, and so on and so on. Okay, things like that. Make sure that you have notes for everything, because you will need it later if something goes wrong. And even if not, if everything is okay, you want to learn from the process. Okay, so take notes and follow the risk analysis plan in case something goes wrong. Hopefully nothing goes wrong, but in case something goes wrong, you should be ready with your risk analysis plan. You should know exactly what you need to do, and not start to make discussions and take decisions and think about what would be the best way to react now. It's not a good time. We are at risk. So the monitoring part, I mentioned it already several times. It's important for testing the application, make sure that it works properly, and of course performance. So monitor performance before and after, during the test phase, and also during the actual deployment phase. Make sure that you monitor. We talked about the importance of having a baseline, of planning the monitoring part, what exactly you want to monitor, which measures, which metrics. And of course you can, again, develop your own script for that, whatever you feel comfortable with, or you can use third-party tools. There are some really great tools out there, like SentryOne, SolarWinds, Redgate, and so on. So depending on your favor tool, use whatever you feel comfortable with, but make sure that you have a solid plan. You know exactly how to monitor performance, and you know how to compare before and after. This is a very important topic. I'm sure that most of you at least are familiar with this. If you upgrade from SQL Server 2012 or older versions to 2014 or higher versions, there is a very big change in the cardinality estimator. Microsoft rewrote this component, which is responsible for estimating the cardinality, the number of rows in each one of the operators in the execution plan of each query. This is a very, very important component, and it has a new algorithm starting with 2014. This new algorithm is only enabled when you update the database compatibility. So the best practice is, when you upgrade, is first to, let's say you upgrade from 2012 to 2019. So now you are using 2019, but still use the lower compatibility level. The database will still use compatibility level of 2012. Okay, so this minimizes the risk. The engine will still behave just like 2012, including the old cardinality estimator. Then what you should do, you should enable Query Store, which is a new feature since 2016. Or if you're in Azure SQL Database, then of course you can also enable Query Store there. And let it run for a week or two, whatever. Okay, so let Query Store accumulate some data about query executions and about execution plans under the old compatibility level. And then you should upgrade the database compatibility level. Now, the reason we need to do all of this, because this is a risky activity. As soon as you upgrade the compatibility level, a lot of things might change, because you're now using a new version of the engine. And one of the biggest changes is the new cardinality estimator algorithm. Okay, so it really improved performance in many cases, but it might also degrade performance in some cases, and this can be really risky. So the reason we do this, you need to carefully monitor the database activity during this change, and you need to identify the specific queries that suffer from worse performance than before because of this new algorithm. And you can easily do this by using the Query Store. This is the reason you want to use Query Store. You can use the regress queries with Query Store, and then you can to begin with, you can force the older plan using Query Store, the plan that is better, using from the old cardinality estimator. And then what you should do is to optimize each one of those queries to be able to get a better plan under the new algorithm. Okay, so this is a risky process that you need to take care of carefully and make sure that you do it right. Of course, continue to monitor throughout the process until you are happy everything is working properly and you are happy with the results. Now, we're done with the project, but we still have some next steps, okay? First, celebrate victory. This is really important, okay? There is a whole team that was involved in this project. Make sure that you communicate to everyone what exactly we achieved. We made it, we achieved this and that goal. Thank you very much, everyone. It was a great success, etc., etc. Okay, what are the benefits that now we can leverage from the new target platform? This is important. Okay, give yourself the opportunity to celebrate. Learn from the process. Remember that we took notes. Now is the time to sit together, everyone, and to learn from the process. What we did wrong, what we did well, what we could have improved. And this is really good to learn as a team how we should improve, how we should do better in the next project. Okay, so make sure you do that, and of course take advantage of new features and capabilities. Like I mentioned earlier, there are lots of things, new features that you can and should take advantage of if you upgrade from an older version of SQL Server. Some of the features are out of the box. For example, intelligent query processing. There are great features like T-SQL Scholar inlining, memory grant feedback, batch mode execution over row store indexes. Lots of great features, and they are out of the box. By just upgrading to the new version of SQL Server and also upgrading the compatibility level, you get them already, and suddenly a lot of queries will get much better plans than before thanks to those great features. For other features, you need to manually enable them and decide that you want to use them. For example, always encrypted. Okay, it's a new feature starting with SQL Server 2016, which allows you to encrypt sensitive data in transit and also in the database itself, and things like data compression in Standard Edition that I mentioned before, all kinds of things that are now available in Standard Edition, things like big data clusters, column store indexes, for example. If you have a data warehouse and you are upgrading for 2008 or even 2012, now in 2019 or even 17, you can use column store indexes as clustered indexes, non-clustered indexes. You can use them alongside row store indexes, and they can really boost performance of your data warehouse workloads. And there are many, many, many others. So spend some time learning about the new features and capabilities in the new versions of SQL Server and also in the cloud. And that was all I had to say about, again, modernizing your data platform from the project management perspective, and also how important it is to plan for such a project. And again, I see from my experience, I see all kinds of good projects and bad projects, okay? Projects that were successful and projects that were not. And by learning from the successful projects, I try to give you all the tools, techniques, methodologies, tips, best practices for how to do such a project in the right way. Thank you very much for attending, for listening. I remind you again, please fill your session evaluations. I hope this was beneficial for you. And if you have any questions, this is a good time for Q&A. Thank you very much.